So our next speaker is a solution architect at Octopus Deploy. He says he specializes in project rescue governance and development methodologies. He's a fan of high quality code. I think we all are, or I hope we all are. Maybe that's why we're here. But so for our next session, let me introduce Andrew Harcourt. Andrew, the floor is yours.
Thank you, Alyssa. Hi, everybody. Hi from sunny Brisbane. It's one of the few places in the world where you can get sunburnt in the middle of winter. So firstly, thank you to all of the organisers. You've done a fantastic job in putting this event on, especially given the very difficult circumstances. Thank you to the sponsors, and obviously thank you to the attendees for turning up, even virtually turning up. Thank you. It's wonderful to have you here. So a little bit about me. So I'm at Octopus Deploy at present. I've spent a lot of time, I've been coding since I was about 5 years old, and that's getting far too long a time to talk about now. Before Octopus, I was at ThoughtWorks as a principal consultant there. I spent some time at Redify, and then before that, in a different part of my life, once upon a time, I was a pen tester. This was back in the days before Meterpreter was a thing. I am assured that the world has moved on. So let's get started with a quick overview. So I want to talk a little bit about doing the right thing. So this talk is about treating security as a first-class concern in our domain model, but I want to talk about why that doesn't happen. So why is doing the right thing so difficult? We're going to talk, the meat of this talk is about security modeling in our domain, how a rich domain model is actually going to help us model our security and be able to test our security constraints. And we'll cover a little bit about infrastructure, not so much as the focus of this talk, but as how this plays nicely together. First things first, though, I wanted to ask a question, and that means I'm monitoring the Brella stream, so please pipe up in the comments if you can. I wanted to ask, who went for a ride today? Who rode their bicycle, or went for a run, or did some exercise of any sort? And I'll be the first to confess that I didn't. My bike stayed on its rack this morning. I haven't done my push-ups, and the reason for that was that I was getting ready for presenting at this conference. That's no real surprise. Who's eaten enough vegetables this week? Now we all know this is good for us, right? Come on, who's eat your veggies, right? Who's drunk enough water? Who's got enough sleep? Why not? And who's patched all their servers? Be honest. Who's patched everything this week? Who can genuinely say, someone went for it, Thomas Griffiths went for a run. Congratulations, one person. So who's patched all their servers this week and upgraded all your dependencies and actually released it to production, right? And why not? Because some of us have, but I'm willing to bet more than a cookie that most of us haven't. So why is this hard? Why is doing the right thing so difficult? And how can we make it easier to do the right thing? So when we're talking about writing secure code, obviously not creating vulnerabilities in the first place is a good thing. But it's not always easy to do that. I just don't write bugs, right? That's easy. Everyone says that. But what if it's hard to reason about the rules? And then let's assume that okay, fine. So we've found a vulnerability. We've identified it at least, which is great. I guess if given the thing exists, we'd rather know about it than not. And we've probably even fixed it. But what if we can't ship? How are we confident that we haven't broken our other functionality? And where this comes to is, well, writing good tests means writing safer code. But what if it's hard to write those good tests? And some of the things that we do in the name of infrastructure automation or in the name of security make it hard to write good tests. Writing good tests really is dependent. I mean, obviously you have to write nice code in the beginning, you have to write testable code, but writing good tests, you need to be able to run them easily. And when we look at where tests run, it's a pretty good indicator of how difficult it is to write them in the first place. And remember, the more difficult it is, the less likely people are to write them well, or to run them, or to care. Right? If I can run all of my tests for the entire application suite on a single dev workstation, and there are dev workstations that can do that unless you're Google, it's pretty simple to just run all of the tests, have it give us an answer in a few seconds, maybe a few tens of seconds if it's a large application suite, and I've got an answer that I'm comfortable with. My tests are green, we're all good, I'm happy to write this, I'm happy to ship it. All right. If we need to, let's start introducing some dependencies though. Let's say, well, okay, it can run locally on a workstation, but it needs a database, which means we're either running up SQL Server if we're old school, or we Docker compose up the universe, or we run something up on whatever local your favorite database platform. We run an in-memory database. Yeah, but it's not as easy. I'm still going to do it because I'm a good engineer, but it's not as easy. It just adds that little bit of friction, and maybe that little bit of friction is okay. But then we look at, well, okay, maybe I need to run kube control apply -f, or actually that doesn't work because I've got to do a whole bunch of substitutions. So now I'm trying to install Helm charts locally just to run all of these tests on Minikube. And we're getting into the realms of, this is getting to be a bit of a chore. If we look at the other end of the spectrum, okay, now I have to do a git push just to run some tests on a build agent. Or worse, you mean the DevOps team is going to run my tests for me, or by the testing team, which is a separate group of people who live in a different building on a different floor, and they probably think that I live in a cave, and I probably think that they live under a rock. And no, just no, this isn't going to happen. We're not going to have good tests. If it's too hard to run them, no one's going to bother to write them. So why does that matter? Well, the problem is that when we talk about composing our application suite, we tend to try to pluck components off the shelf. And this is a good thing. Right? If you're rolling your own authentication framework, that might be your core business, but otherwise you're probably doing it wrong. Likewise, if you're putting logic in your API gateways, that's probably not the right place for it. The difficulty is that everywhere we outsource logic, we also make it more complex to test. If I can test a self-contained little component, then I'm going to be a whole lot more confident than if I have to spool up an instance of an API gateway or a firewall or a this or a that. So when we're outsourcing, we need to be very, very careful about what we choose to outsource and what we don't. As a fundamental principle, you outsource only your periphery. You outsource the commodities. You don't outsource the core of what you do. Unfortunately, that will contrast quite starkly with the messaging that you'll get from enterprise middleware vendors who want to sell you everything, where you end up with clever pipes and dumb endpoints rather than the converse. So we want to give some thought to what is sensible to outsource. So we're going to play a little game first. This is called Spot the Bug. All right. Now, this bug, it doesn't currently appear in the OWASP top 10, but it usually makes appearances here and there. You'll spot it pretty easily. And I will promise to send, so I'm in Brisbane, Australia, I will promise to send you a Byron Bay cookie in the mail physically to the first person who can put a message into the chat telling me what this bug is. So welcome to our cafe. We're giving away coffee. It's awesome. Unfortunately, this is a virtual conference, so this is virtual coffee. Our incremental cost of goods sold is 0. Nonetheless, welcome to DevSec Cafe 24. Let's have a look at this. So this is a little app that I spun up earlier. It's our free little cafe application, and it's got some woeful security holes in them. Some are deliberate, some are just to put the scaffolding there. So what we're going to do, I'm logged in as Andrew at the moment, but you can see there's no password, there's no authentication, that doesn't really matter. What's the bug? So I'm going to log in as Andrew. And I'm going to go to my orders collection. This is my order history. So let's have a look at my order history. And you can see that I haven't drunk all that much coffee today. I've ordered a flat white with 1 sugar, and I'm going to view its details. That's your cue, spot the bug. Now I'm going to copy that URL. I'm going to go back to the homepage, and I'm going to log in as Damien. Andrew, Nick, and Damien, by the way, are just 3 mates. They'll likely heckle each other a little bit, but nobody here is malicious. Nonetheless, there are 2 my orders in it. That's actually a good catch, but it's not the bug. These are queues. The 1 and 2 are queues for me, so I know which one is which. This one is the not secure one. This is the slightly more secure one. Good catch, though. Good attempt. Floor is still open. Have a go. What's the bug? So I'm going to log in as Damien. No, that's not the bug either. You can see that I've changed. I'm now in my user context as Damien. And if I go to Damien's order collection, we can see that Damien's coffee order is the extra shot flat white. And we can view its details, and we can see, okay, so I'm logged in as Damien. This is an order for Damien, and there's an extra shot flat white there. Session invalidation, good guess. What I'm looking for, you'll spot it in a second as soon as I go to the address bar. What's going to happen when I hit paste? I'm going to paste that previous URL in. I'm going to hit enter. Oops. Logged in as Damien. I can see an order for Andrew. We've got a direct object access bug. How did that happen? Am I an idiot? When I wrote this thing, what was I thinking? What I was thinking, and I'm going to bring up the code for a second. Now, don't freak out. It's just code. It's not an alien. This is the code. This is the code that has the bug. You are correct. Your guess is that you can go to another person's account. You can't go to their account, but you can go to things that are owned by them. And the reason for that is because I've got a weak, anemic domain model here. And you can see this, right? We're taking an order ID as a route parameter. We're materializing that directly from an order repository, and then we're just mapping that to our view model, and we're putting it straight onto the screen. We're not even checking for who owns this order. Whoops. But be honest. Who's never, ever, ever written code like this? I was thinking about my next copy. I didn't have it. And you can see that our code tool, our resharper, is actually even telling us, hey, you've got this logged in customer thing that you are not using. Maybe you want to deal with this. The bug isn't actually session management. This will work even if it's nobody. If we're logged in with absolutely nobody, this will still work. So let's have a look at what this code could have looked like instead. So let's flick back to this one and have a look here. So here's our bug. It's direct object access. I can paste in a URL and I can access stuff. Now we've got one saving grace, which is that it's a GUID, so it's a little bit harder to inspect, but it's still not that hard. And here's our bug. I've taken a dependency on an order repository and I've gone and fetched that. However, if we tweaked that very slightly, what we could have done is we could have used our ORM and our rich domain model to help us out here. We could have said, rather than just going straight to the orders repository, what we're going to do is we're still going to take the order ID from our route parameter, but then what we're going to do is we're going to resolve the logged in customer. We are then going to go from the customer via their orders collection to get that order ID. Now, if this order doesn't live in that customer's orders collection, it doesn't exist. We get a 404 instead. So if I go to the slightly different implementation, which is going to do that, what we'll end up with is a 404. Pretty graceless 404, but it's a 404. Happy days. Obviously, we've dressed that up a lot more nicely, but there we go. So a richer domain model would have saved us even in this elementary manner. So let's talk about domain modeling and let's talk about rich domain models and how they can help us. I'm going to make a couple of non-contentious statements and then people are going to freak out. So you just watch. So a couple of principles. If there's a thing, there should probably be a class for that thing. This is OOP 101. If there's a thing called a customer, then there should probably be a customer class. And if there's a thing called an order, then there should probably be an order class. Likewise, if there's an action, there should probably be a method that represents that action. So something can do a place order. And so what we'll end up with is something like this. We have an order class, we have an order placing service, and wait, what? So like a wild order just appears out of nowhere. Oh, well, I mean, yeah, I guess so. No, this is terrible code. And if you were thinking, actually, this doesn't look too bad, it looks neat and tidy, that's actually part of the problem. This code is terrible. It's dangerous, and it's even more dangerous because it looks neat. Well-formatted code can still be terrible code. What's wrong with this? Well, we've got a bunch of things. One, the domain model is completely anemic. Our order class can just be manipulated. It's basically nothing but a dumb state bag. The second thing is that things can be done to that object by everyone, whenever. And we don't really know what's been done to the thing. We can never assume it's valid. We can't really trust it. And what that means is that we tend to outsource a whole lot of our precondition checks. This is terrible. Don't do it this way. Please don't do it to yourself. So the principle that's going to be a little bit contentious, even though it shouldn't be, is whoever does the thing should own the action. Rather than an order placing service, we want to have a place order method on our customer. Now, we'll probably still have some kind of order placement service, but what it's going to be responsible for is resolving our customer and telling it to do a thing, giving it the dependencies that it needs if it needs anything, giving it the information it needs to make its decision, and then telling it to do that thing. So the reason for that is that the things that have actions performed on them must consent to having those actions performed. So if we look at a really, really simple cafe model, right? We've got our customer, and our customer has some orders. So it has some behaviors. And in this case, our customer's behavior is place order. And we're going to place an order with a barista. All right. So our customer is going to make up an order. Hi, I'd like whatever my current order is, please. And I'm going to call barista.accept this order. Now, this is mimicking what happens in real life. In real life, you walk into a cafe, an order doesn't just magically appear. You communicate with someone. An actor in the system communicates with another actor in the system. Both of them have to agree on what's going to happen. So in this case, when we look over at our barista class, what we can see is that the barista has an accept method, which takes an order and a customer, and the barista can say no. Now, this is really, really important for security as well as for our domain logic. So it's an internal method. It's not a public method, so we can't just call it from outside. But if we have a look at the precondition checks, what we can see is that the barista can refuse for any reason they like as long as it's valid and lawful. So if the barista is on their lunch break, no, I'm not making you coffee, I'm busy. Right? Likewise, if you're just a rude customer, then you're not welcome here. No, I'm not making you coffee, go away. But assuming that the barista is actually not on their lunch break and that I'm a polite customer, and given that I like my local cafe, of course I'm going to be polite to them. Given that I'm a good person, hopefully I'll be polite regardless. But the barista is going to check their preconditions, and if they're happy and they will consent, they will perform the action, they will undergo the state change. We're all good. So what does this have to do with security? Well, what we can do is we can prevent actions from happening unless everybody involved, every party involved, consents to that action happening. Consent given or withheld for various reasons, and rich domain models can actually have a meaningful opinion. If we've just got a dumb state bag, it doesn't know if it's legal to do a particular operation. But if we have entities that have state and behavior, then they can say, look, I'm willing to perform that action or I'm not, or even I'm willing to let you read that information or not. This isn't just a change control mechanism. This is also a read control mechanism. So if we're going to put a whole bunch of logic onto our customer, so in this instance, I've only got a place order method, but if we're actually going to try to shoehorn all of this logic into a single customer class, isn't that going to be a disaster? Well, I mean, yeah, we'll end up with a deity object customer class, and that's a very bad thing. Don't do it. However, what we've just discovered, though, is we've actually got a domain modeling problem. We've got a context boundary problem. Our customer is operating in different contexts at different times, and we need to represent that in different ways. So if we look at some of the methods on this customer, let's see if we can group them. So we've got a place order, we've got a sign up, we've got cancel our account. Yeah, they can request an extra shot. That's probably something to do with placing an order. Tipping might be, or it might not be. Making a complaint, no. Asking for the key to the restroom, different context. Likewise, although in Australia, visiting the restroom and stealing toilet paper was actually a thing. Apologies, world. We will do better than that. Likewise, sneezing. 6 months ago, we wouldn't have cared if a customer sneezed. Now, we really do care if a customer keeps sneezing somewhere. That's saying something that we might want to pay attention to. But all of these actions tend to be done in different contexts. So what we want to do is we want to look at introducing some role-based classes for some of our customers. Some of our actors in the system can be the same physical entity, but modeled in different ways in different contexts. And what this allows us to do is start codifying some of our constraints around our domain. To Mohammed's point earlier, we can automate some of our compliance constraints by doing this, just by writing tests around who can do what, under what circumstances. And we can also document those via the tests that we write. So if we start splitting out some of the actions into role-based classes, then we can say things like, well, rather than this customer can do a thing, a loyalty club member can redeem a reward, and a complainant can make a complaint. Yes, they might actually be a customer. Side note, don't use inheritance, use composition or object graph traversal, but they're the same physical entity being modeled in a different way for a different context, and that's perfectly okay. So the question that immediately pops up is, isn't this just like role-based access control? And your enterprise middleware vendors will be jumping up and down and saying, hey, but this is exactly what you should use an API gateway for. Or you know what? We've got an enterprise service bus that's just for you that will do all of this for you magically so you don't have to worry about it. And they'd like you to believe that. And some of them themselves do believe it. And there are good cases to be made for using enterprise middleware in some cases like this. But let's give some thought to this. If we just state a really simple constraint, only a loyalty club member may redeem rewards. That looks pretty okay, right? You've got a role, loyalty club member, and you've got an action. You can do that, yeah, no worries. Let's take a slightly more serious example. Only a doctor can review a patient's chart. Yeah, fair enough. All right. Now, in reality, there'll be other people who can review a patient's chart, but let's say for the sake of argument that we have a role, doctor, we have a role, patient, and doctors can view patients' charts, except that that's not how the real world works. The real world gets a little bit more messy. If we say only a doctor may review a patient's chart, but only when that doctor is treating that patient. Yeah, well, okay, we could probably model that by just adding them to a security. Ooh, we do have a bit of a cross-product problem, though, because we're going to have security groups for an intersection of doctor and patient, or maybe we make some assumptions about, well, this patient is attending that hospital, so all of the doctors at this hospital can do that. Yeah, we can still do this with an RBAC system. Yeah. Oh, okay, this gets a little bit harder. So only a doctor can review a patient's chart, but only while that doctor's treating that patient or for 3 months afterwards. But that's still not how the real world works, is it? We all know this. This is a whole lot more like the way the real world works. And all of a sudden, we are way beyond access control lists. We are way beyond being able to outsource this to anything like an API gateway. We can try, but what's going to happen is our API gateway is going to have to learn a whole lot about our domain, which means our API gateway gets smart. So now we've got a smart pipe and a smartish endpoint. Where do our tests run? Well, to run all of our tests, now we have to spool up everything. We've got to spool up an API gateway with all of the smart logic in it, as well as our application, which has still got some smart logic in it. Now this means we're probably not going to be able to run it on a developer workstation, and the developers in the audience are looking at this going, oh man, you just made me sign into Azure or the AWS console, and you're not my friend anymore. So that might be the end of it, but it's actually not. It gets even more complicated than that. We've got really, really, really complicated business rules about who can do what, when, under what circumstances, what the exceptions are, and then we've got to write all of this down in a codifiable way. We've got to be able to honor our compliance obligations by saying, hey, these are the rules that we applied at this particular time to give this person access to perform that action to this subject and so on. Right? We're not in RBAC territory anymore here. This is not going to work. We need our domain logic to be responsible for answering these queries and providing these constraints. So if we look at something like what we can do is we can say, well, you know, if you're one of these things and you can do these you can perform these actions under those circumstances, we can use something like the guard pattern. It's not particularly complicated. We can say, well, a loyalty club member can only do a thing if their membership's current. They might need a reward point balance. We can put a guard method onto our domain objects that allows us to give really complex, high quality reasons why an action may not be performed. This is really, really going to be helpful. But the fundamental principle here is that I can write a test for this, and this can run in process, in RAM, on a single machine. It'll run quickly. It's easy to reason about. And if I get it wrong, I'm much more likely to care about it because I'm much more likely to be able to fix it. If I push this to a build pipeline and I have to wait for an hour or a day or a month, I'm never going to care. So if we need something slightly more sophisticated, let's have a look at the guard pattern, which we can do in a minute. But the fundamental principle here, though, is the logic has to hold up. If I don't have to break into your system, right? I don't have to wander in and take your database. I don't have to look for remote code execution exploits. I don't have to do any of the proper black hat stuff if your system just gives the data away. We want to put logical constraints in so that we can say these things are only permissible under those circumstances, and our domain logic, which will test that for us, will hold those constraints to be true. However, there is a flip side. And this is where I put on my black hoodie and say, well, I don't have to break your logic if I can just drop Meterpreter in one of your boxes and exfil your entire database. So this is where infrastructure comes into play. Now, we're not going to talk too much in depth about infrastructure security. We've got a bunch of other speakers who are going to do a much better job than I will on that. I do want to say, though, a few things about how our domain modeling and security principles can play nicely with infrastructure security. So let's say, for instance, that we have found a vulnerability. We're going to have a bad day no matter what. We're already having a bad day, right? There's a CVE, it's been released. We've discovered that somebody else has got a remote code execution exploit, and it's in our systems right now. We've got to do something. What can we do? Okay, well, clearly we should patch it. Can we patch it? Do we know? Have we patched it? Do we know? Ugh, okay. Now, if this is in our infrastructure, what we should be able, let's say, for instance, there's a remote code execution in the Linux kernel, because that'd never happen. Windows kernel, maybe that'd never happen either. That's why you run all your Docker containers on Linux, people, side note. But nonetheless, what we can do, though, is we can just patch the operating system, right? And we can redeploy all of our stuff. Except that if we have a really convoluted test suite to run, then I'm preaching to the choir here, we know that that's going to be really difficult. We have to spin up an entire VPC. We have to run all of our infrastructure just to run this little regression suite when our code hasn't even necessarily changed. Infrastructure as code is going to help, but if we're still not confident that our tests are going to catch anything that we've broken, then we can't really ship this thing. So we need our domain logic to be rock solid so that we can then say, look, if the tests pass, we're confident that this thing is able to be shipped to production. We know that we haven't introduced any logic errors into our business domain. We know that our security model is fine and it's helping us out, and our API gateway is just going to be shuttling packets backward and forward and doing some elementary checks on our auth tokens, which means we can safely upgrade our infrastructure. We can just bump our base AMI image. We can do all of those things that we'd otherwise look at and go, oh, gee, those servers haven't been patched in 3 years. They're probably vulnerable, but no one's noticed yet, right? Maybe no one will continue to notice. That'd be good. Right. Infrastructure changes are scary because our app might break. But if our app is confidently able to be tested, our app's not going to break. But nobody here knows how to do that, do we? Surely there's a community of people who know how to do this somewhere. Maybe one day we'll find them. So I'm going to throw it open for a QA. This kind of talk normally prompts a whole lot more questions than the normal, especially around things like ORMs and N+1s and God objects and so on. So I tend to leave a little bit more time for questions in these kinds of talks. But if you do only take one thing away from this talk, other than a need for coffee, it should be this. Your domain model needs to be the final arbiter of who can perform an action, when, and the conditions. Everything else is an optimization. It doesn't mean that it's a bad optimization. It doesn't mean you shouldn't do it. Absolutely, you should be checking API tokens at your API gateway. You should just be saying, look, if they're authenticated, then they're allowed to call this thing. Maybe if they're authenticated and they can do this thing, or in that role, then they can do this thing. But you know what? I'm just going to pass on the fact that I know who they are and what roles they're in and a set of claims, and everything else can be taken care of by the application, which has its logic, which can be tested. Optimizations aren't bad. They're very good. They're very necessary, but don't rely on them for the correctness of our application. Everything else is an optimization. Your domain model has to be the guiding principle, the one final determinant of who can do what, when. The second single thing I'd like you to take away from this talk is that under pressure, good people do things that are familiar and easy, not unfamiliar and difficult. If you make it easy to write good tests, if you make it easy to run good tests, good people will write and run good tests. They will give you reliable outcomes. If you make it really difficult to release something, if you make it really difficult to test something, if you make them sign into 2 different cloud consoles just to figure out which API gateway gave them this weird token that's a little bit broken, they're not going to want to do it. We want to make the pit of success broad and deep so that people easily fall into it. Make the right thing to do the easy thing to do. Everybody wins. On that note, thank you. I'm going to throw the floor open to questions. I saw a couple of notes earlier. So questions. Nobody's asked me about N+1s yet.
So just a reminder, if you got questions, throw them out there into the chat with Umbrella. And Andrew will be more than happy to take those questions from you. We have a few minutes here to take questions. So if you've got something to ask, please throw that into the chat.
So so while we're waiting for questions to come in, I see that there's one that's arrived already. While we're waiting for questions to come in, what I might do is I'll flick over to some of the terrible code that I wrote, and we can have a look at some of the logic. So in this case, what we've got is a customer class that's not particularly sophisticated. Okay. But you can see that they've actually got the beginnings of some state and some behavior here. Now, I'm relying on, in this case, a made-up ORM. In .NET land, obviously, we'd probably use something like Entity Framework. Obviously, in Java or Kotlin land, you'd probably still be using Hibernate. You can use a whole bunch of these. It doesn't really matter. What we're looking for, though, is persistence, ignorance being our friend rather than our enemy. The problem that we usually see when people begin bringing in an ORM is something like order collections. And we've seen an example of that a little bit earlier. So if I grab one of the tests here, what we can see is we're asserting in this particular test when a customer signs up, they start an order. So when a customer places an order, customer.orders should contain order. Now, DBAs are likely to freak when you show them this kind of code, because what you're saying to them is, I'm going to materialize one record followed by 1,000 records because I'm going to materialize this entire orders collection. Right? It's really important to note two things here. One, the database is subservient to our domain model. The database is an implementation detail of what we're trying to do, which is model the real world. Two, ORMs are not like they were in the early 2000s. ORMs are actually pretty good. An ORM, given a query like this or given an expression like this, is going to issue maybe two, probably one queries. Probably only one. In the case of VF, it's likely to be two. It's going to fetch this, and then it's going to fetch all of these. And we want the details of these. It's still going to just do a left join, even if we pull in the order line items. So we need to rely on our ORMs. Treat the tools as our friend, not as our enemy. One of the other considerations that we were looking at, and this is a sneaky one, this bites people a lot. I'm going to flick back to one of these, which is the guard pattern. And specifically, now somebody would already have spotted this a little bit earlier. Put it in the chat if you have. Can I pay for my order with points? And the first question, the first precondition we're checking here is, well, is their membership current? Now, what's the problem with the word current? Because pretty much immediately, anybody who's written any code anywhere in a system that crosses time zones, they're going to go, we don't know what time it is. Right? We need to know what time it is. That introduces the concept of a service. We need to know what time it is, because we could call this method today, and we could call it tomorrow, and it may well be correct in giving us different answers. So that's easy, right? All we do, well, a membership is current, it's just a dumb property, right? We can just hydrate the records from the database when the membership lapses, and then we can update them all and say, well, now it's not current anymore. And I guess you could do that, but we're hoping to have more than a handful of customers, and that's going to get really expensive if you've got a decent sized customer base. So what we can do instead is we can introduce the concept of providing a domain service to an entity at the point in time when it actually needs it to get an answer. So in this case, can I pay for an order with points? Here's the order. By the way, the time is this o'clock. Is my membership current? Can we pay it? What's the points balance? And so on. Where we end up is we actually end up passing some relatively trivial services into some of our methods, or we run our domain services earlier. So for instance, we have a clock service, and then we just pass in the result. So if we grab our clock service and then we say, okay, hey clock, what time is it? Okay, cool. Now, loyalty program member, can you pay for an order with points given that the time is blah? What that allows us to do is keep our components very, very functional. We can keep our guard methods effectively stateless and serviceless. They don't need services. They just get pure inputs and get pure outputs. So that's one of the normal issues that we tend to see with code like this. And where people tend to go wrong is they inject services into their domain entities and then they hold on to them for a very long time. So what you end up with is trying to serialize a database connection, or you end up with object disposed exceptions, or in the case of C++, you end up with segmentation faults because you try to dereference a pointer that's now been cleaned up. So maybe don't do it that way. But this pattern does have a lot of value. One of the things that we tend to find, though, is that when we start thinking in OO terms, we realize just how difficult a job we've created for ourselves by extracting so much of this logic into services that previously we thought were well factored. When we've pushed all this logic to outside, now we're in all sorts of strife because all of a sudden we're bossing these entities around from outside, but they're starting to have opinions about whether they're actually willing to undertake those kinds of actions themselves. So we end up in this kind of one foot in either camp territory where in some cases we've got services doing manipulation, and in other cases we've got the entities doing the manipulation of themselves. That's normal. It's actually not as bad as you think. Oftentimes, it's actually pretty easy to start refactoring a code base to this kind of pattern, and it pays off in spades. So I'm going to leave it there. If there are no more questions coming through the chat, then we'll call it a day.
You must have done that good a job. Nobody's got any additional questions. You explained it that well, I guess.
Either that or everybody's just gone to sleep because I was boring. We'll see what Twitter says.
Awesome. Well, thank you so much, Andrew. Really appreciate you being here with us.